Welcome back, everybody. Let's dive back into our history. Now, I have thrown in these two people. They weren't on the initial timeline, but they're quite interesting characters. So I want to show you what they looked like and what they did. So the first guy is this one here. He looks like quite a jolly fella. He is Stanzileo Canizaro. Okay, please excuse my pronunciation. He is a Sicilian chemist, and Sicily is quite close to Italy. He would have been Italian. He's spoken Italian. Sicily is where all the mafia came from originally. Okay, the gangsters. But he was very interesting because he, in 1858, he began weighing out the different elements, and so he came up with the atomic weights, atomic masses for individual atoms of elements, and his work was very precise, and that is why this wild-looking man over here, Dimitri Ivanovich Mendeleev, he is Russian. He liked Stanizaro's work because his work was precise and accurate. And Dimitri, I'm going to use his first name because his surname is so difficult to say. Dimitri was a Russian chemist, and although he looks a bit wild, he was particular and pedantic about putting together the structure of the periodic table. Now, the periodic table we use today is a very important piece of information that we use, and this man was the man that put it all together, and he constructed the systematic approach for putting all the elements together, how he grouped them, he looked at their behavior and why they needed to go in a certain place and not another place. So he was very, very instrumental in creating our periodic table. He did that in the 1860s, so this would have taken him quite a bit of time to do. So he developed a system of atomic weights of elements determined by Avogadro's theory. Now, Avogadro is another guy that we come across when we're dealing with stoichiometry, and that means that we're dealing with calculations, we're looking at volume, we're looking at mass, we're looking at molar mass. We use Avogadro's theory when we work out those calculations. Now, I've thrown in here Henry Becquerel and Pierre Curie and Marie Curie, and they were involved in radioactivity. Now, what they managed to prove by proving radioactivity or finding it was that the atom is not indivisible. It's actually, you can divide it, because that is what radioactivity is. It is particles that are emitted from the atom. And so they were French. Henry Becquerel was a French chemist. He found X-rays. He discovered X-rays perchance. Pierre Curie was a renowned French physicist. He was extraordinary in what he did. He unfortunately died very young. He was run over by a horse cart, and his skull was fractured. He was 46 years of age, so that was a great loss to the physics world. His wife, Marie Curie, is probably who you know best. She was Polish, and she was an incredible woman. She used to take tarmac, bitumen, and in these huge cauldrons she would stir and heat and try and isolate the compound that she was, or the element she was looking for. And she discovered radium and she discovered palladium, and she is also known for her contribution to the treatment of cancer. So she's a real force in our science history. Now, J.J. Thomson progressed our atomic theory further. He was a British physicist, and he was the first to discover a subatomic particle, and that was the electron. So you can see we've gone from what we think, what the earlier scientists thought of the atom, which was long before him, to now, which is 1903. about 100 years later, he discovers the first subatomic particle, which is the electron. He says that it is a sphere, that the atom is a sphere. He says it's neutral, that there are equal number of positive and negative charges within it. We know it as the plum pudding theory. Okay, so here we start the development of our atomic theory. The next guy was Ernest Rutherford. Now, he was born in New Zealand. He ended up in Britain. He is known as the father of nuclear physics. Nuclear meaning what's inside of the atom. He did this famous experiment, the scattering experiment. He used alpha particles being the center of helium, and he shot it at this gold foil, and he came up with the most amazing results. You need to go and have a look at that to see what those results are. But from his results, he said this about the atom. He said that there is a very, very small charged nucleus. It is surrounded by empty space, and a tiny, tiny electron moves in that space. And so here is the picture of his atomic structure. You can see in the center there is that charged nucleus, and the most part of the atom is surrounded by this space that's taken up by very, very small electrons. Niels Bohr is the next guy, and he was a Danish physicist. He, in 1913, came up with this idea that electrons have got different amounts of energy and that they are moving in separate areas, which we call orbitals. And so, separate orbitals, this is his structure, and you can see now that they're not just all over the show, these electrons, that they are more contained. And here, if I draw around here, you can see orbital 1, orbital 2. Okay, so the electrons are then moving in orbitals according to their energy that they possess. Now, Schrödinger, this very happy man here, was an incredible mathematician. He figured out, using these long, long mathematical equations, the space in which an electron will move. We know it as the Schrödinger wave equation. He was involved in quantum mechanics, a very big word that you'll only get to when you get to university. But he found that these electrons move in an area, a volume, a 3D space, and they have got a shape to them. So you can see over here in this one some of the shapes that he discovered all through mathematical calculation. There's some more over there, very weird looking shapes. And this is what we know today. So this is what you will do at school level. We'll talk about the s orbitals, these ones over here, the s orbitals. The two of them, the s orbitals inside. And then these p orbitals that look like dumbbells or a figure of 8 shape. That is the area in which, or the volume in which you will find an electron moving. So let's have a quick look at where we've come from our very beginning, which was with the Greek philosophers, and that's before Common Era. So they started off with this. Okay, so this is a bowling ball. You know, if you go bowling, Skittles bowling, you got this heavy ball that is rigid, that is indestructible, it is heavy, it is solid. So that is the very first idea of the Atamos, of the atom that makes up matter. From there, we move to this idea here, which was Thomson's idea. That's the plum pudding idea of a neutral atom that has got positives and negatives, and he was the first one to discover the negatives, the electrons. Okay, from there we move on to this idea here, and this one was that we have got the center being charged, and that is the nucleus, and that we've got this space that is taken up by the electron. The electron movement actually creates the space around the center of the nucleus. Then we move on to Bohr, and Bohr's idea was that, Niels Bohr, was that the electrons actually are very ordered, and they move in designated areas or designated volumes around the nucleus, and they're called orbitals, and there are layers of them. Then Schrödinger came up with a more defined and accurate look to what those orbitals are and their weird shapes, and that was Schrödinger. Right, everybody, I hope you enjoyed learning a bit about these amazing people and how they've influenced us. Please join me next time. We are going to take this atomic theory further, so come and join me. See you later.